Hello, everyone. Welcome to this live webinar on scraping data for generative AI. Before we begin, just a reminder that you can submit questions at any time in Slido, and we'll do our best to get through as many as possible. If we don't get through them all before our time is up, we may run longer than scheduled. If we can't answer everything, you can reach out to us on our AI web scraping channel on Discord, where members of the community will be able to answer your queries. Also, if you have to leave before we finish, you'll be able to watch the recording after the live stream has finished to catch up on what you missed. So let's get started. What has Apify got to do with generative AI? Apify is a web scraping and automation platform, and all generative AI solutions begin with web scraping. All large language models are trained on scraped data. GPT, for example, was trained on 575 gigabytes of text from the web. Even image models like Midjourney are trained on scraped web data. Also, web scraping isn't a one-and-done activity when it comes to building generative AI models. You need to constantly feed and fine-tune them with relevant and up-to-date information to continuously improve them and customize them. One tool that helps achieve this is Website Content Crawler, which is one of the many web scrapers in Apify Store, and which was designed specifically to collect data for large language models. Another powerful tool is LangChain, which has fast become the library of choice for building on top of Gen AI models. And we're going to demonstrate how using the LangChain Apify integration can help you feed and fine-tune LLMs. That's why Yindra is here with me today, because he is the lead developer of Website Content Crawler and tooling developer at Apify. And he also works on our open source web scraping and browser automation library, Crawley. So Yindra, before you show everyone what these tools can do, could you just say a few words about Website Content Crawler? Why was it created and what problem does it solve?
Thank you very much for such an introduction, Theo. Maybe before I start, if you have any questions, as Theo said, you can submit them in Slido or in the chat here in YouTube, either here or there. We have Jirka, who is also ready to answer your questions, so depends. And if he cannot answer your questions or doesn't manage to answer them, we'll look at them in the end too. Okay, cool. Now let me switch to our slideshow here, so our viewers don't have to look at our faces when we'll be talking about Website Content Crawler. And let's take a look at it. So your question was, what is the Website Content Crawler for? Why did we make it? Well, it all started with this one question we had for the GPT 3.5 Turbo language model. We asked it, what is Crawley? As you mentioned, Crawley is the open source library we're using for web crawling and web scraping. It's for Node.js, it's on GitHub. If you are using JavaScript, feel free to check it out. Now, GPT 3.5 Turbo answered, Crawley is a web crawling and data extraction tool, which is so far so good, even though it's a library tool, okay, developed by OpenAI, which is not true. They just blatantly stole our library. And okay, now that you think, all right, so maybe the language model doesn't have knowledge about, who made what. And for some applications of models that can be all right, let's say for checking grammar or spelling in a text, it doesn't need extensive knowledge of, products that are out there. Or also for entertainment, for writing scripts for videos. That's okay, it can be useful if it knows something about the outside world, but it's not absolutely necessary. Another thing is creative work, right? Again, it might be useful if it knew a bit about things it's writing about, but it has to be creative, most of all. So these kind of mistakes are okay, are fine. Now, for some applications of large language models, these mistakes aren't okay at all. Let's say for any high-stakes environment like law practice or medical expert systems, these mistakes the model makes can lead to huge problems loss of money, it can lead to somebody hurting someone, which is terrible. Okay, also when you're making business decisions, if the large language model gives you a bad idea what to invest in or whatever, that's terrible when that happens, right? Now, you might think that nobody would trust a large language model with their life or their money or their law problems. Well, a recent study shows that around 78% of people, of respondents of that study, were willing to self-diagnose themselves using ChatGPT. And that's, even though the study can be biased, it's still a huge number, right? And another study shows that around 72% of respondents of this other study from BICS countries, Brazil, India, China, right, and South Africa, they do trust AI in general with their medical issues, with their law problems. And that's still a very, very high number. Now, okay, here are links for the studies if you want to check them yourself. And why is this? Why do people trust large language models? Why is ChatGPT such a huge phenomenon? It's mostly because it speaks natural language to people. It speaks English, it speaks Czech. Okay, Czech is our language because we are here in Prague. And it speaks the language of the people who are using it, and you can create some sort of a social relationship with that model. It feels almost as if you had a friend there, and therefore you tend to somehow take those things it tells you as more trustworthy, as something you should trust better because, it's the ChatGPT telling you. Now, we can't really say this is stupid thing to do because it's in the human nature to anthropomorphize. Is that correct?
That's it.
Wow, first try. Because if you look at this, there is this. It's just a piece of stone with some plastic eyes on it, with a piece of paper. But people tend to see a face in there and maybe assign some kind of personality to it. And that's the same thing that's happening with large language models lately. And therefore, there's this huge challenge for the 21st century and for developers of large language model applications, AI applications in general, creating user-safe AI systems. Really tell users that, it's not another person behind there. It's not an expert. It's just a model that gives you answers based on some probabilities it learned from some data somewhere. Okay, now that we see that there is this problem, let's take a look at how we can solve it. Just to remind ourselves, the problem we had was that the large language models usually don't have knowledge about very specific items, our products, in our case, Crawley. So how do we teach them? How do we tell them that, okay, Crawley is a library developed by Apify? Now, there are, let's say, two approaches to this. Let's take a look at this first one. In this case, we have a large language model here. That's the one we, buy from OpenAI or any other organization that trains large language models, and they did this part where they took a gigantic large language model training set and they trained the model. Okay, so we get this as a product, and then we take data from our knowledge base. It can be the documentation of our product, something like that. And we can feed this to the large language model and fine-tune it, basically modify the model so that it knows a bit more about our specific use case, that it knows that Crawley is a library made by Apify, for example. And as a result, we get this fine-tuned large language model, which, as I said, knows about our products, knows about our stuff. Now, where's the problem in this? Well, first things first, training the model costs a lot of money. But that's usually not the problem because we already got the model from somewhere, so it might be pricey to buy it, but the price of or the cost of the training isn't really something we have to we have to pay ourselves. Now, of course, fine-tuning the model will also take some time and some money based on, depending on how big the knowledge base is, depending on your use case. It can also be a reasonably high amount of money. Now, the real problem, though, is that once you start running the large language model, you'll use up a lot of money. Why is this? Well, the model is fine-tuned. That's not really the issue here, just the fact that it's fine-tuned. The problem is that it's fine-tuned only for our case. So we have nobody to split the bill with because we'll have a very highly specific large language model nobody else can use. So all the costs, go after us. There's this, we can fine-tune some of the models on the OpenAI infrastructure. For example, I think it's only the GPT-3 models, not the 3.5 nor 4. You can train some of the older models and fine-tune them. But even that, even though you don't spend crazy amount of money on infrastructure and hardware, it's still reasonably pricier than running the state-of-the-art models, GPT-4, GPT-3.5. So this is usually not the case, not the way we want to go. Let's take a look at something else, large language models with database integrations. Let's, in here, in this case, the large language model is the final product, the fine-tuned one. When you have a question or a prompt, you take the prompt and you ask the large language model, and it gives you the answer. With the database integration, this process is slightly longer, but it allows us to create a whole pipeline, make it more scalable, make it much less costly, and it's much better in general. Now, here we go. We also start with a question, but we don't pass it directly to the large language model, in this case, with the database integration. We pass the question to something called Smart Retriever. Now, Smart Retriever, what is it? That's just a regular Python script, Node.js script, C++, just a regular program. We're not in the AI realm yet. This program will query a database and retrieve documents from the database. This is the database containing our knowledge about our products. Let's say the documentation for crawling. This database is usually implemented using something called a vector database. Basically, this is a full text search, but a bit stronger.
Could you give us an example of a vector database, or say a
Oh yeah,
little more about them for those who are not familiar with them?
yeah. These are like what are those names? Pinecone was one of the very popular ones. Online closed source database. We have Weaviate. I think that one is open source. And we'll be looking at those while we'll be integrating our data with the LangChain framework. Now, the vector database gives us the relevant documents from that database, the knowledge about our product. Okay, sorry. Now that we have the question and the documents that are relevant to this question, we can pass this all to the large language model, which now can be any large language model. It it doesn't have to have any specific knowledge about our domain, because it's all the context, all the knowledge is passed with the question as the prompt. So one thing that's great, because we don't have to run our own customized large language model. Another thing is that it's greatly scalable, because you can use OpenAI's models for this and only pay for what you use. Now, it's great, and this large language model generates the answer out of those documents and the query. Another thing that's like a huge upside, and it might not be immediately visible from this, is that with the previous case, you get an answer from this fine-tuned large language model, but you don't really know where that answer is coming from, because all the knowledge of your domain is somehow encoded into the large language model. And that's not the case with the database integrations. Sorry, let me skip right here, because here you can also retrieve the documents that the answer was generated from. And therefore you have the sources, and you have like web pages you can access to learn more about it, and it serves as a great user experience tool. Cool. So now that we know what we'll be doing, let's take a look at how to feed the knowledge base or how to create the knowledge base. Because you can have you can have your product's documentation, but how do you export it to the vector database? Well, you can use our website content crawler. This is how we come back to the initial question. Because web is full of data. Probably even your product has some kind of a documentation online. And it's there, it's accessible, and it's mostly freely available. Open source products or open source projects show us that integrations with large language models, integrations of the data from the web, can be very, very useful. We can see a lot of projects in this GitHub repository. There are many different applications that integrate data from Notion, from your Notion database, from your documentation. And these all are, a very, very cool and useful use cases for a large language model. Now, you might think that, okay, if there's a website out there on the internet and I want to use their data, I probably should scrape it, right? They just won't give me the data themselves. But if I want to create some, let's say, language model or chat assistant for my documentation, why should I scrape my own website? Why don't I just export it from the database under the documentation instance? Well, there are multiple reasons. One of them is that content management systems aren't really good at exporting data, and there is extra work with exporting the data from the database and feeding it to the vector database or feeding it to the large language model. With Website Content Crawler, you have that in a neatly packed JSON format. There is also a better user experience if the large language model gives your users the answer and also a list of links where it took the answer from. And with Website Content Crawler, you can do just that because with every website it scrapes, it stores the link and it provides that to the large language model. So, it can answer with the links, the URLs to the articles it used when creating that answer. Also, thanks to the fact that the website content crawler is running on the Apify platform, you can schedule it to run periodically to always have the most recent data. Or you can use it, you can run it on every update of your website. You can integrate it with GitHub Actions. There are many different options you can do. And the very last a reason why you should be using Website Content Crawler is that it's a one solution that fits all of your use cases. If you have to integrate multiple websites with large language models, you can do so with the Website Content Crawler using a unified interface, and it's all very quick and easy to do. Okay, I think that's it from our presentation.
Right. So now you're going to demonstrate this tool for us?
Yes.
Okay.
Please let me see. Let me find it. Here we go. Right. Just a quick moment. Hopefully our viewers can now see the Apify Store. And now, yes, so we're at Apify Store and we are okay, Apify Store, if you've never seen it, it's this front page where you can see all the actors you can run, all the programs you can run on our platform, and one of them is the Website Content Crawler. Now, when we click it, we see the README here and the green button Try for Free, which when you click, you get to the console, or if you're already in the Apify console, you click the Store tab. And here you basically see the same view, and you can start a website content crawler from here. Now, here we see the input tab of the website content crawler. There are multiple inputs, and we'll be going through them. First and foremost, you have the Start URLs option. That's basically maybe the most important, not maybe, definitely the most important option there. Because here you put the URL in, URL of the web page you want to crawl, you want to scrape. So we'll do it with our crawly documentation. Let me go to crawly.dev And here we click Docs, and we get to the documentation. Here we see that the introduction chapter, for example, has URLs that end with /docs/introduction, or well, the path name of the URL starts with /docs/introduction. And all the articles in the chapter, as you see, they all have the /docs/introduction part in their URLs. And that's a very important thing, because that's how the crawler knows how the uh, documentation is, how the chapters work there. And if you want to scrape only one of the chapters, this is what the crawler will be using. If we take a look at the other chapters, for example, guides, you see that it contains /docs/guides in there. And only the articles in the introduction chapter contain /docs/introduction. So we'll take this. Sorry. We'll take this URL, and we'll copy paste it here in the here we go, in the console. Now, for the other settings, what we have here are crawler settings. The crawler type here, you can basically pick what browser you want to use. We have different browsers. We have Chrome, we have Firefox. Firefox is a bit better at overcoming Cloudflare bot protection, or basically any bot protection that's out there. So you might want to use that by default. But we'll be using the raw HTTP client Cheerio because it's much faster than the browsers. The downside is that it works only on well, HTML pages without any dynamically loaded components with JavaScript. But we know that our documentation is just like that. It's server-side rendered. So we'll be using the HTTP crawler. So it's super fast. All the other options, they are sort of like self-explanatory. We have the max crawling depth. That's basically how deep will the crawler go before stopping on your web page, how many links basically it will well, pass. And or other limitations like the maximum amount of pages. Or something very interesting, the setting initial cookies allows you to provide cookies in case you want the crawler to log in into some kind of a web page. You can provide the login cookie there, so it uses the cookie to basically authorize itself at the web page and get into the logged in part. Now there are some details about how you should format them. I'm sure you can go through that if you're interested in that. Another very cool option is the proxy configuration. That's also connected with the blocking, because some pages can block your IP address if there is some unusual traffic coming from it. And Apify integrates proxies and allows you to use those proxies in the crawlers you use on Apify. Here we have the proxy tab. You can check the settings on your account for the proxies. I think we'll just use this one here, automatic. Again, if automatic doesn't work for you, you can pick some other ones. In the HTML processing tab, there are some details about how, because when you crawl the web page, you then want to process the data somehow, for example, to remove all the navbars and all the menus. And you can do that internally in the website content crawler, so you can only just harvest all the great clean data. Here you have some details about dynamic JS loading. And here you can specify the CSS selectors of the elements you want to remove from the web page, like the menus, the navbars. All right, then there's this very cool option, remove cookie warnings. That's good for, I don't know, it's called cookie warnings. I wrote it there, but there's like cookie model, cookie.
I actually don't remember.
Yeah, I'm sure our viewers know what we're talking about. These, like, do you accept these cookies? It's probably European Union or GDPR thing. Not sure. But using our crawler, using this option, you can remove them from the web page, so they're not in your resulting data. You can also use some HTML transformers that clean the data even more, or remove some duplicate text lines in your output. And in the output tab, you can pick whether you want to save HTML, Markdown. Very cool option there is that if you want to save files like PDF or Word documents, Excel documents, you can do so using this. It will store those documents in the key value store on Apify, and you can just consume those through our REST APIs. Now, cool. And the last option here are the general options. Here you can pick how much memory the crawler should be using on our platform. That depends on the plan you're on with Apify. I think we have 32 gigabytes on this account. But as I said, that depends on your plan, how much memory you'll be allowed to use. Now we click the green button with Save and Start, and we have some time to talk about live before the actor starts and grabs our data, but it's not too long. We can click the Log tab, and here we'll be seeing basically the console output of the program. Here we see that it's already doing something. On the output tab, we'll be seeing the results of the crawl. Here we already can see that it goes through the web pages, which is great. It's pretty fast, right? As I said with the Cheerio crawler, it's faster than the browsers, but even the browsers aren't that slow really, because there is this problem that it needs to load the JavaScript, so obviously it has to be slower. Now that we look at our chapter here, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 articles, and we can see that the crawler also extracted 9. Okay, that's because of the initial chapter article. That's 9 in total. Here we have the links to the articles, and on the right side we have the contents of those articles. That's basically the data we'll be feeding to the vector database straight. In the storage tab, when we click that, we can pick to get that data in JSON, and after clicking this, we see this whole JSON document. We can export the data in CSV if that's easier for you, in case you're using like Pandas or some Python tooling. We can use export the data in XML, in JSON as one line. Really depends on your use case, really. We'll be fine with this JSON document, I think. Now, we see that the URL of the data set doesn't contain any token. That's a very developer-friendly approach. If you want to only download the data set, you don't have to use any tokens at all. You can just use this URL, and it's accessible from your software immediately. Yeah, okay. That's, I think, pretty much it. Cool.
Fantastic. Okay, so let's say someone uses this to collect their data. Where do they go from there? Are there any other tools or things that will help them in the next step of the solution?
Yes. Well, now that we have the data, I would like to, show our viewers how do we use the data with the LangChain integration. For that, we'll switch to, here we go, VS Code, and let me find the window here. Here we go, it's on this screen. Cool. Now, LangChain, for those of you who don't know it, is basically a framework for creating large language model applications, for integrating large language models with your data, which is exactly what we'll be doing in a second, and basically a tool for creating large language model applications. Now, we have a basic example here and example of the integration with the knowledge base we just created by scraping our documentation. If you look at this basic script, it's actually the LangChain is very, very user-friendly, at least I think so, because all you have to do is to create this sort of a large language model chain, something they call the chain, which is basically the whole pipeline you'll be using for prompting and getting the answers from it. What you have to specify is the large language model you'll be using. We'll be using OpenAI. More precisely, it's their model GPT 3.5 Turbo. If you have access to GPT-4, you can use it here. If you have any, tweaked models, fine-tuned, you can specify it through here. And you can set other options for that model, like the temperature here. It's basically the entropy it will have when figuring out the answer. Temperature 0 means that it'll give you a very straight answer. If you set it higher, it can get a bit more creative and also a bit more random. Now, another thing we specify in the chain is the prompt or prompt template, which is basically what the large language model will be solving. In our case, we said here, answer the following question and query. So if we call the chain here, and we set the query as what is Crawley, it gets, here in this place, the query parameter here gets replaced with what is Crawley, and the whole prompt for the large language model is answer the following question, what is Crawley? And okay, so we call the chain, we basically call the model with this question, and we get the response, and then we find it. Then we print it, sorry. So when we run it, I hope this will work. It might take a bit, but hopefully not too long. Here we have our answer. So we see that, again, the model told us that Crawley is a web crawling and data extraction tool developed by OpenAI. This is actually the example I used for the initial slide in our slideshow. Now, to solve this problem, we'll integrate our data set in this with the large language model, so it knows what is Crawley actually. Okay, so we look at this more advanced example. Let me see if our viewers can still see it. Probably. Yes, cool. And now, this example is a bit more complicated, but not that much. What we have here is the dataset loader, Apify dataset loader. You can load it from this package here. And we specified the ID that was actually part of the URL. You just take that of a URL of the dataset. You just take that, you put it in the program, and you're golden. Another thing you might need to do is this dataset mapping function, because the dataset can be an arbitrary JSON object. But the large language model requires the documents to be in a certain format. More precisely, to be actually a document object with page content field, which will be text from our JSON, and metadata field, which will contain the source, the URL from the dataset items of the URLs of the articles we scraped. Once we have the loader, we load the documents and we split them. This is not absolutely necessary. I created a splitter here. Basically, splitter just takes the documents, we load it, and well, splits them into chunks. So it's harder to hit the maximum context limit for the large language model. Basically, from the huge documents, it creates a bunch of smaller ones. And there is some overlap between those documents. You can parameterize all of this in the code. It's, again, very, very intuitive and simple. Now that we have our documents loaded and split, we load them into a vector store. We are using HNSW. Again, a very, very simple intuitive interface. We just provide the documents. We say that we want to use the embedding service by OpenAI by just saying this. Now watch out, if you'll be doing this with every query, the database will have to recalculate the vectors or the embeddings every time you run this, so you might want to cache this, but for our use case, it's there's like 9 documents, so it's very, very simple, and should be also fast and very cheap. And now to the actual core of this program. It's this retrieval QA chain. It's just basically slightly customized large language model chain, but it's pretty much the same thing. It's just tweaked so that it works better with answering questions from with this knowledge base, in this knowledge base scenario. Now, Again, we specify the model we want to be using. It's the same one. You can see that we set the temperature a bit higher so it can get a bit more creative with the answers. We say that we want to use this vector store we made from the documents we scraped as the knowledge base, as the retriever for the documents. We say that we want to use at most 5 documents, the most relevant ones for the answer, for the question, for creating the answer, and that we want to learn what documents we used once we get the answer. And from here, the usage is pretty much the same. We again call the large language model or the chain with the query. This time I picked a different query. That's how to cap the maximum number of requests scraped with Crawley. That's something I know there is in the pages we scraped. So the model should be able to find an answer to this question and give us the answer. Okay, so now let's try to run it. Okay, knowledge base, hopefully like this. Okay, and when we press enter, again, we'll wait a minute. The program, it's going to take a bit longer, not that long, because the program has to retrieve the documents from the data set, create the embeddings, and then use the large language model, and it's all on network, basically. All the services.
I see something's happening already then.
Oh yeah, it has finished actually. And here we have our answer already. So you can cap the maximum number of requests made by using the max requests per crawl option, which is correct. That's yes. As a Crawley dev, I can say that this is a well formed answer. And here we have all the URLs of the web pages the model used when creating this answer. And that's pretty much it. This is how you integrate your data from the web using website content crawler and LangChain. Very simple, very intuitive. Yeah.
Brilliant. That's really, really quite fascinating. I'm a little conscious of time because I know we're going to have questions coming in, but maybe before we get to that, maybe you could just quickly run through some other features of the Apify platform that might help people with AI solutions.
Certainly. Let me find the slideshow we have for that. Present to view. Here we go, and let's switch to that. Here we go. So other Apify tools, you said we have to be quick. How quick?
1 minute.
Really quick. Oh my god. Okay.
As long as you need.
All right. We've seen that a lot of our viewers are coming not from our platform, but from organic search. So in case you don't know Apify Store, Apify is a software as a service platform, and we offer both the software and the infrastructure you can run it on. The software in our infrastructure on our platform, it's called Apify Actors, and an actor is basically a Docker container with some input parameters. And output of these Docker containers can be anything. Usually, as we've seen, it's a JSON document or some tabular data, but it can be pretty much anything, binary. As we've seen, the website content crawler can download PDF documents easily. Now, with Apify, you can either create the actors yourself or pick some in the store. And that's what we've seen again with the website content crawler. There was an actor from the store. And now the runs of those actors can be scheduled, called via API programmatically. You can also get the data programmatically, as we've seen in our example. So it's all very nice and easy to use, and also very, very powerful. And we'll right now take a look at some AI-related actors. Let's start with extended GPT Scraper. It's pretty much what we've just seen, but somehow simplified and simplified and all packaged into one nice, neatly packed actor. All you have to provide are URLs and a prompt, and you'll get a human-readable answer for each of those pages from those URLs. So, for example, you provide these 3 URLs. All of those are Wikipedia articles. One of them targets Daft Punk, another one is about geese, and the third one is about Czech Republic. And the prompt you provide is summarize this page in 3 sentences or less. You feed all of these into the extended GPT Scraper, again, either as we've seen it with the website content crawler in the platform, or you can do it by API, and you get an answer that Daft Punk is a French DJ duo, geese are birds, and Czechia is a country. And these answers are basically made by GPT, the GPT model that has knowledge from those URLs. The scraper actually scrapes the page and then feeds it to the GPT model. Basically, as we've seen with our example. Cool. Another thing, not really generative AI, but it might be interesting, is the AI product matcher, which is a program or an actor that finds matching pairs of products in two different online store datasets. Let's say you have eBay and Amazon datasets of, let's say, laptops, and you want to see which laptop is really matching, which laptop from eBay is really matching the product from Amazon. It's very cool, and you can use it for setting competitive prices in case you are you are running an online store yourself or finding the best deal. Really, there are plenty of use cases. Another very cool thing is the Google search results scraper, which does exactly what you'd expect it to do. It scrapes Google search results based on a given search term. So you give it a search term, and it gives you basically the whole Google search page as a JSON or as a CSV file. You can use this to run your SEO applications or integrating Google search in your AI chatbots. Just imagine you can take the large language model and actually connect it to Google search so it can retrieve documents, and then you can maybe crawl the pages from that search results. It can be very, very strong and useful application. And you can customize a whole bunch of things like the country, geolocation, language, desktop or mobile search. That's probably useful for the SEO applications more. And now we've talked about Pinecone as a vector database. We have an integration for it and the Apify platform. It's a cloud vector database. You basically just send them your documents, and then you send them the query, and they give you the relevant documents from your database instance. It's a very low-cost, highly scalable solution, very modern. And using our integration, you can import data from Apify datasets straight into Pinecone. You don't have to, download them from our platform, upload them there. It goes straight one-to-one. And you can not only export the results of your actors, you can export results of any of the actors from the store into the vector database. Again, very useful for large language model integrations. And I assume that's the last thing we have here are the Llama uploaders. Llama Index is a data framework for large language model applications, not dissimilar from what we were using, LangChain. It's pretty much the same thing. And with Llama Index, you can connect data from various data sources with large language models, just like we did with LangChain. And Llama Hub is this, let's say, repository for those loaders, for those data loaders. And we have two loaders there, Apify dataset, which allows you to consume datasets from the Apify platform, feed them to your large language models, or you can run Apify actors and again feed the results of the runs to your large language models. And that's it.
Brilliant. Thank you, Jindra. So it's question time.
Cool.
So we'll try to get through all these questions as best we can. Some questions actually came in before we even started, so it's possible that some of the questions we actually already answered. If that's the case, we may just quickly skip over those questions. Don't take it personally if we do that, just for the sake of time. So first question, Jindra. Would you compare existing models and how they fit into the use cases, like knowledge-based scenario versus OpenAI, Llama, Alpaca?
Right. I assume that we've already answered this question. As you've seen, the models on themselves, they cannot answer some specific questions regarding some, specific domain knowledge. With the knowledge-based integration, those can answer these. So,
Okay.
Yeah.
All right, so we'll move on to the next one.
Mm-hmm.
Is there any way Apify can crawl LinkedIn jobs applicants, get fit ratings and emails from the nested menu they're hidden in, and then feed those into our systems?
Now I assume this is not directly AI related question, and you just want to scrape data from LinkedIn and feed them into your systems. And that's definitely something Apify can do. We do have LinkedIn scrapers, although I'm not sure if this is applicable for your use case, but definitely feel free to try them out. I think some of them are free, hopefully. Or if you don't find an actor that fits your use case, feel free to let our developers know on Discord, and you might find somebody there who can help you with that.
Right. Looks like we have another LinkedIn related question.
Oh.
Complete code for crawling my LinkedIn and ResearchGate profile to generate summary cover letter from optional prompts. There may be input from job advertisement.
That's a bit confusing, but I think, well, we went through this before, so I sort of understood what it's about. Basically, if I understand it correctly, you want to crawl your LinkedIn profile and ResearchGate profile and generate customized cover letters for different job applications. That's what I'm assuming. Well, you can definitely crawl LinkedIn with our actors, and crawling your LinkedIn profile, that shouldn't be any problem. With ResearchGate, I'm not exactly sure if we have a ResearchGate crawler in Apify Store, but again, if we don't, well, if we do, feel free to check it out. If we don't, just go to our Discord, and maybe you'll find somebody there who can make it for you.
Or build one yourself.
Well, yeah, exactly. Yeah, that's what we want you to do. Yeah, for the cover letter generation, you can definitely do that with the large language model. As we've seen, you just don't use it as a question answering model. You just tell it, write me a cover letter, and it should work just fine. So that is somehow, yes, possible with Apify too. Yeah.
Next question. How should or could we address the limitation of the crawling method introduced in the webinar?
No, I'm not sure what.
Now, this question actually came in before we started, so I'm not quite sure which limitation crawling method is referred to. Maybe if you put a comment in the YouTube comments or in the Discord channel, maybe someone would answer there, because we're not quite sure what you're referring to here. So we'll move on.
Also, right now you can still submit questions in Slido.
Yeah, you can still do it. So if you want to do a follow-up question, you can do that quickly.
Exactly.
Okay, next question. How do I prevent hallucinations? I'm trying to extract reliable data from the web and currently use OpenAI's GPT, but in uncertainty, it starts making up info.
Now, that's a great question, because that can still happen. If we asked, for example, our LangChain integrated large language model about something that wasn't in those pages we scraped, it might try to make something up. And I think the maybe easiest way how to go around this is to, set it in the prompt. That's how some of the LangChain, predefined chains do it, that they tell it, answer this question, and if you don't know the answer, just don't make anything up. Just say, I don't know. And so that should work. Other than that, I'm not really sure. Maybe setting the temperature lower, right? So so it doesn't get as creative with the answer generating. But yeah, that's that. It's definitely, hallucinations are a huge problem in any large language model application, as we've seen with the initial slideshow.
Okay, next question. Can the creation date of certain website data be considered by the LLM? Example, you scrape a website, but you only want to use data from the last 7 days as input.
That's definitely something you can do, and you definitely want to do for some applications. If you, I don't know, if you're consuming some data from news sites, you don't want to be using, dated news articles. You can do that. It's not really something you do when tweaking the large language model. It's something you do, on your infrastructure. For example, you prune your database regularly, so you remove the old articles, so the model only has access to the latest ones. Or you can have some metadata with the articles, and tell the vector database retrieve the most similar or the most relevant documents for this question, but only those that are newer than some set date. So it's definitely a great use case and something you can do with today's technology. Yeah.
Okay. Next question. So, an example prompt. Agent, go to these 100 news orgs, find archive pages, write a scraper for last 100 articles. Is this possible with current tech, or will it require GPT-5?
Now that's pretty cool idea. Basically creating, if I understood it correctly, creating scrapers for some web pages automatically and then running them, I suppose. Yeah. Okay. That's yeah. I think it is possible. The problem is really the integration of the large language model with the way it accesses the internet, because by default large language models don't have internet access, and you have to provide it somehow, let's say via the LangChain, to create some sort of like a loop where it finds something on the internet, processes it, and then makes another request. uh, I don't really think this depends that much on the strength of the large language model. It's exactly more about this stuff that's around it, about this tooling. Another thing we've noticed, we've tried parsing HTML with the GPT models. It didn't go that well, but that was some time ago, so that might be already resolved. But again, I don't really think you need any newer models for this, but you definitely need a lot of time to create all the tooling around it.
Okay. How can we automatically qualify lists of thousands of company websites with AI? Input URL, output answers to 2 to 3 questions about site content.
Now, I think this question is already answered
It's done.
because,
Okay.
yeah, well, we got it from the extended GPT scraper, right? You feed it
Ah, yes, of
URLs,
course. Yeah.
right? You give it a prompt and it gives you the answers.
Okay. Extended GPT Scraper is the answer. Okay.
Exactly.
Next question. How can we store the output in a useful way for later indexing the content into a vector database with relevant metadata?
All right. Well, the way we're doing this with the website content crawler is that, well, it just stores the outputs in JSON, and we found that it works just fine. So just use JSON. It's easy to parse. In case you don't want to use JSON, you can use any other textual formats, but I don't think there is no need to get too fancy. Just use something that's widely available, and it should be just fine.
Okay. We're already over schedule, and we've got more and more questions coming in, so I don't think we're going to get through all of them. But we'll go for another 5 minutes. We'll try to wrap up in the next 15. Yeah. So if there are any questions of yours we don't get to, you can put them in the comments on YouTube or in our Discord channel, and we'll try to get back to you. But we'll get through as many as we can. So next question how can I store non-text info in a structured and useful way for the LLM? Example, CSS styling, hyperlinks, images, graphs.
Now with CSS styling and hyperlinks, I think these still are text info, so you can just store it as text. As I've said, we don't know how well. We found that the language models weren't that proficient in parsing HTML and probably CSS as well. So that's even though you can store it and it will try to understand it, it's the results may vary. Now with images and graphs, I'm not too sure. I read some articles about integrating language models and with some other kinds of data like videos and images. It's a very let's say academical thing, and I'm not sure if there is any commercial solution right now that can integrate a language model with images or some binary data. So yeah. Perhaps if you want to process images, you might want to process their metadata, so the time they were created, the content somehow extracted by other tools, and you can process that with the large language models, but perhaps not really the image data itself.
Okay, next question. We work with retailers. Their data quality varies, and we need consistency. How can Apify identify, find, collect, and track missing product information?
Now, I believe we have some datasets analyzers, something like that. or it's definitely work in progress. Um, definitely, if you want to, if you want to solve this problem of data quality, you'll have to start by manually checking it, not manually checking every single record, but just seeing how well the scraper runs on the site at least like once in the very beginning. Yeah, I don't think there is an automatized solution that can qualify whether the data is good quality or not.
Okay. How does the crawler handle highly rate-limited targets like medium? Is there a way or need to do automatic proxy rotation with retries based on the results?
That's something we've seen. Actually, well, I just mentioned it. You can use the Firefox browser, which also has some bot detection evasions pre-installed in it. So we found that works pretty well against rate limiting, and as you have seen, the proxies at Apify work also very well. And there is automatic rotation inbuilt, so you don't have to really care for that when you're using Apify.
Perfect. I want to scrape new data to update my database regularly. How can I make the actor smart enough and also price efficient to only crawl new data?
Now, this is a tricky question because to know that you're crawling new data, you have to crawl some old data first to see that there is some difference. I don't think the website controller can do this, but it's still reasonably fast, so you can always crawl the whole website. You can also specify that you don't want to. It basically depends on page-to-page basis. If some pages have some like query parameters that say from and to, you can always set the dates only to the most recent one or the date of the latest crawl. Without any more details, I cannot really help you with this, but it's definitely something you can work with.
Okay, I think we're only going to have time for one or two more, unless they're really quick fire questions. I'm using the website content crawler for crawling e-commerce product URLs, and the results are not the same when I use FAISS, F-A-I-S-S. I think it's Facebook AI search. I've forgotten the name of it. Similarity search,
Yeah.
instead of ChromaDB.
And well, here we got the answer. I think it might be from Jirka. It's just the fact that those databases are different. They have different vector embeddings.
Okay, great.
So the results can be different.
Can I search Google and scrape specific parts of the websites in the results? Pages are similar.
Can I search Google and scrape specific parts of the websites? I assume so, yeah. If you can't do it with the website content crawler, you can use one of our other generic crawlers like Web Scraper, Playwright Scraper, and you can actually specify the selectors or even the JavaScript code that will extract the data from the website. So that's highly customizable.
All right. I'm sorry, I don't think we had time to get through all of these questions, but I think we probably should wrap up because it's been an hour. But like I said, you can leave a comment in the channel or in our Discord channel or in the YouTube comments. But yeah, thank you so much, Yindo. That was a really fascinating demonstration. Thank you everyone for joining us and for your wonderful questions. We did our best to answer as many as we could. Before you go, there will be a little survey at the end that will just take you 1 or 2 minutes to let us know how this webinar was for you and so on. Don't forget also, like I said, to check out the Discord channel, like and subscribe to this channel for future content, and you can check out the resources that we will have in the description. I think that's about it, so we can wrap up here. Thank you again, Yindo, and
Cool.
thank you everyone.
Thank you,
Take
Theo.
care.
Okay.